Hi students, I hope you understood what we have discussed in the previous session about the division of some numerical terms we expressed and even algebraic terms I explained. We have discussed those division of algebraic terms. So in that we have even come across the division rule. We verified division rule. What is division rule? Dividend is equals to divisor into quotient plus a remainder. So dividend is equals to divisor into quotient plus a remainder. Now, when it comes to the polynomials, in that the degree, based on the degree, if the smaller degree is there, then greatest degree we cannot divide. P of x is a polynomial in variable x, g of x is a polynomial in variable x, q of x is a polynomial in variable x, r of x, it may be the constant term or maybe it is a monomial or binomial based on the given question. So here degree, once we see what exactly the degree, we learned we already discussed in the previous session what is the degree in the polynomial in given variable, in the polynomial for the given variable, in polynomial for the given variable, the highest power is called degree of it. The highest power, that is also whole number power, positive power. So the highest power. Now dividend is equals to divisor into quotient plus remainder. For the polynomials, dividend is equals to divisor into quotient plus remainder. In general, p of x and g of x are two polynomials is that the degree of p of x is greater than or equal to degree of g of x. Sometimes p of x is nothing but here polynomial x dividend, which is called dividend. G of x is nothing but divisor. G of x is nothing but divisor. So degree of p of x is greater than or equal to g of x. Sometimes it may be greater, sometimes it may be equal. So degree of p of x, degree of dividend is equal to degree of divisor than g of x, and where g of x is not equal to 0, then we can find the polynomials if you have dividend and the divisor, where p of x and g of x. P of x is what? Dividend. G of x is what? Divisor. If you have, then we can find, if the degree of the polynomial p of x is either greater or equal, that is the symbol what shows, greater than or equal, then we can find more two polynomials, quotient and the remainder. We can find more two polynomials. What are those? Quotient and the remainder. So we can find quotient and remainder such that we find that d of x, that is dividend is equals to divisor into quotient plus a remainder. P of x dividend, g of x divisor, q of x quotient, r of x a remainder, where r of x is equals to 0. Sometimes remainder may be equal to 0 or the degree of r of x is less than the degree of g of x. The remainder always will be less than, the degree of the remainder is always less than the degree of g of x, that is the divisor. That's what we have discussed in the previous session. Every time the remainder, even numerical terms also, when you divide 21 divided by 6, 6 is the divisor, 21 is the dividend. So remainder will be always less than the divisor. The remainder is always less than the divisor. Then only your division is right. So p of x is equals to g of x into p of x plus r of x, where r of x is equals to 0 or degree of r of x is less than the degree of g of x. Here we say that p of x is the dividend, p of x is divided by g of x, gives the quotient as q of x and r of x as the remainder. R of x is the remainder. This is the division rule. Dividend is equals to divisor into quotient plus remainder. With this we are extending towards the remainder theorem in the polynomials, towards the remainder theorem. So based on this, one more example I will explain the division of polynomials, then we go to the remainder theorem. Once you see here, example, find the remainder obtained on dividing p of x cube plus 1 by x plus 1. So this is p of x, that means this is the dividend and this is the divisor, which is nothing but g of x. See here, so p of x, this is the dividend. P of x is equals to x cube plus 1 and g of x is equals to x plus 1. X plus 1. Now what we are doing? We are dividing x cube plus 1 with x plus 1. We are dividing x cube plus 1 by x plus 1. This is the dividend, this is the divisor. Observe, the degree of p of x is greater than degree of g of x. So degree of p of x is greater than degree of g of x. Or sometimes it may be equal, then only the division you can do. If it is this degree is less than this, then the division we cannot. In numbers we learned how to divide, converting into decimal, but here the degree of p of x must be greater than degree of g of x. Even you can write as 1 by, but you cannot simplify further and further. Now, so when we are dividing with x plus 1 is the divisor and x cube plus 1 is the dividend. Now you observe it. Here I do the rough work for you. This is the rough work what I am explaining. X plus 1 you are dividing with x cube plus 1. So this x cube, first term in this and the first term. So divide it. To get the quotient x cube by x, which is nothing but x into x by x gets cancelled, you will be having x squared. So x squared. With x squared you are dividing, you are multiplying this x plus 1. With x squared you are multiplying this. So x squared into x plus 1. X squared into x cube plus x squared into 1, x squared. So x cube plus x square. See, you are not writing this under this. You are not writing this under this. Are you following? This term is different and this term is different. Now, when you subtract minus, so these two terms gets cancelled. And what it has no other peg. It is only minus x square. So minus x square. Bring down this term plus 1. Now you see the quotient. To get the quotient, we are using this minus x square. With this you are dividing by x, which is nothing but minus x into x. We are not writing minus x into minus x. Minus is different here and x square is different. That means minus x square, not minus x whole square. So by x cancelled, then minus x is the quotient. So right here minus x is the quotient. Now with minus x you are multiplying this. So minus x into x plus 1. Minus x into x plus 1. Minus x into x is minus x square. Then minus into plus, minus x into 1 x minus x square. Do you have the term x term over here? No, we don't have. Minus x. Next, this becomes plus. These two gets cancelled. Plus x. Then bring down this plus 1. Plus 1. Now when you write this divided by this, so x by x gets cancelled. It will give you 1. So that is plus 1. With 1 now you are multiplying. 1 into x plus 1, x, 1 into x plus 1 into 1. So that is x plus 1 minus. Cancel. The remainder is equals to 0. What is the remainder? 0 you obtain. What is the quotient? X square minus x plus 1. X square minus x plus 1. So q of x is equals to x square minus x plus 1 and r of x is equals to 0. R of x is equals to 0. Reminder, you see now r of x, where r of x is equals to 0 or degree of r of x is less than the degree of g of x. Sometimes you may get or you may obtain here a binomial or a monomial or a whatever the term, degree will be less than the degree of the divisor and the degree may be 0. So we obtained r of x is equals to 0. Now if you assume remainder is equals to 0, that means what can you say about this? What can you say about this x plus 1? X plus 1 for the dividend x cube plus 1. Suppose I give example 12 divided by 4. What can you say? 4 is the root, 4 is a factor of 12, right? 4 is a factor of 12. That's the reason we are getting remainder as 0. So this is x plus 1. When you divide, you are obtaining the remainder as 0. So here I am explaining that the next part over here, observe it. We are explaining that p of x is divided by g of x and the remainder is 0. What we obtain remainder is 0 we obtain. The remainder is 0. Now when we obtain remainder 0, think this one x plus 1 which is g of x plus 1 is equals to 0. X plus 1 is equals to 0. I am just explaining what is x plus 1 is equals to 0. If x plus 1 is equals to 0, the root of x plus 1, which is nothing but, which implies x is equals to minus 1, means if you substitute in place of x as minus 1 in place of x, then this you will be obtaining 0. X plus 1 is equals to 0, as we learned 0 of the polynomial in the previous session. So if x plus 1 is equals to 0, which implies x is equals to minus 1. Now if you substitute this minus 1 in the polynomial p of x, you will obtain definitely the remainder 0, because here you obtain the remainder 0. Now you see p of x is equals to x cube plus 1. Substitute x place minus 1. P of minus 1. What we are doing here? X place we are putting minus 1. X place you are substituting minus 1. So p of minus 1 is equals to minus 1 whole cube plus 1. So minus 1 whole cube minus 1 into minus 1 into minus 1. Minus into minus plus into minus. 1 ones are 1 ones are. So that is minus 1 and plus 1, which is equals to 0. So p of minus 1 is equals to 0. Now you see, when you divide with x plus 1, you got the remainder 0. You found the root of x plus 1, the root 0 of the x plus 1. 0 of x plus 1, that is minus 1. When you are substituting that minus 1 in place of x in the dividend, then you are obtaining the remainder 0. Remainder 0. I hope you understood. From this we are extending the remainder theorem. This is the division method, and we are finding the root of the polynomial, of g of x, 0 of the polynomial of g of x. That value we are substituting in the dividend, then we are obtaining the same, which is the remainder is equals to 0. P of minus 1 is equals to 0. P of minus 1 is equals to 0. Is it clear, children? Yeah, now we see the remainder theorem. What exactly the remainder theorem is? The remainder theorem, let p of x be any polynomial of degree greater than or equal to 1. Degree greater than or equal to 1. This is 1. And let A be a real number. Let A be a real number. Here we are checking the remainder theorem. How the remainder is going to be obtained without actual division. Without actual division. Let P of x be any polynomial of degree greater than or equal to 1 and A be a real number if P of x is divided by the linear polynomial x minus A. You see here, linear polynomial. Linear polynomial means what is the degree of it? Degree of the linear polynomial is 1. So, degree linear polynomial x minus A, then the remainder is P of A. The remainder is P of A. Here P of A is nothing but what is 0 of this polynomial? 0 of this linear polynomial x minus A is equals to 0, then x is equals to A. That means in place of x you are substituting 0 of this polynomial. Now let P of x be any polynomial with a degree greater than or equal to 1. Suppose when you divide the P of x with x minus A, suppose that when P of x is divided by x minus A, then we are obtaining the quotient. We are getting a quotient which has q of x and the remainder is r of x. If you divide, definitely when you divide two numbers, a quotient and remainder, maybe remainder will be equal to 0 or may not be equal to 0, but definitely we obtain the quotient and the remainder. So that's what, when you divide P of x with x minus A, the quotient is q of x and the remainder is r of x. Means P of x is the dividend, x minus A is the divisor and q of x is the quotient and r of x is the remainder when you divide P of x with x minus A. Here P of x is equals to, as the dividend rule, division rule is what? Dividend is equals to divisor into quotient plus the remainder. So P of x is equals to x minus A into q of x plus r of x. Now we see the degree. First I explained in this today's session, I explained about what are the degrees, how the degrees must be for the quotient and the dividend and the divisor and the remainder. Now the degree of x minus A is 1. Because why it is 1? Because it is a linear polynomial. Because the x minus A is a linear polynomial. X minus A is a linear polynomial. So linear polynomial degree is 1. So is 1 and the degree of r of x. So now the remainder degree of r of x must be less than the divisor or it may be equal to 0. So degree of less than the degree of x minus A. Degree of r of x, sometimes it may be equal to 0 and sometimes, which means r of x is a constant. Sometimes it may be constant also. So say for every value of x, r of x is equals to r. When it will be r of x is equals to r? Sometimes if r of x is equals to 0, so that remainder is a constant. Now P of x is equals to x minus A into P of x plus r. Dividend is equals to divisor into quotient plus a remainder. Now 0 of x minus A is, so in the previous example we discussed, after the long division I explained with 0 of the linear polynomial, that value we substituted, even we got the same remainder, how we got the actual division, and when we substituted it's 0 of the divisor. 0 of the divisor we substituted. So 0 of x minus A is, x minus A is equals to 0, which implies x is equals to A. So we are substituting in this place P of x in place of this. In place of x we are substituting A. So x minus A means x place we are writing A minus A into q of x plus A you are writing and r. A minus A is nothing but 0. 0 into something, anything, 0 into anything is 0 plus r. 0 plus r is equals to r. So P of A is equals to r. That means this is how, if the linear polynomial degree is less than 1 and it is, the remainder is always either it should be less than or, that's what degree of r of x is less than the degree of x minus A, dk of x minus a. So if it is 0, then it becomes a constant. So p of a is equals to r. That's what we substituted in the previous question. When we substitute some value here, 1 and minus 1, then you obtain the remainder as 0. Sometimes it may be 0 or sometimes it may be the number. But we are substituting a. For why we are substituting a? We are finding the 0 of the divisor. 0 of the divisor. That value we are substituting in place of x. This is the remainder theorem. Now, example is find the remainder when x square plus 2x plus 3 is divided by x minus 1. X square plus 2x plus 3 is divided by x minus 1. Observe it. Solution. P of x. Let P of x is equals to x square plus 2x plus 3. X square plus 2x plus 3. And division. This is given x minus 1. This is divisor. So x minus 1 is given 0 of x minus 1 is 0 of x minus 1 is, we are finding its 0. In the previous exercises we found the 0, how to obtain the 0 of a polynomial. So 0 of x minus 1 is x minus 1 is equals to 0, which implies x is equals to 1. If you transpose this minus 1, what we will obtain? Minus 1, if you transpose this side, what we will get? Minus 1. If you transpose 0 plus 1 is equals to 1. Therefore, x is equals to 1. I hope you understood here. X minus 1 is equals to 0. If you transpose minus 1 this side, it becomes 0 plus 1, which is nothing but x is equals to 1. So when you are substituting x is equals to 1, now this x value, x is equals to 1, we are substituting in place of x in the dividend. So that is p of x is equals to x square plus 2x plus 3. What is x value we are substituting? 1. P of 1 is equals to 1 square plus 2 into 1 plus 3. 1 square is 1 plus 2 into 1, 2 plus 3. So 1 plus 2 plus 3 is equals to 6. Therefore, P of 1 is equals to 6. That means, therefore the remainder is 6. What is the remainder? P of 1 is equals to 6. So what he is asking, find the remainder when it is divided by. So the remainder we obtained as 6. Even if you do actual division, we obtain the same remainder. This is the remainder theorem. Based on this is how we obtained the remainder with examples. I hope you understood, children. Yeah, now we see from exercise 2.3 some questions we discussed about the remainder theorem, how to obtain the remainder. Now, find the remainder when x cube plus 3x square plus 3x plus 1 is divided by the second bit in that x minus 1 by 2, and in that fifth bit 5 plus 2x. So we see now what is p of x is x cube plus 3x square plus 3x plus 1, and the divisor is x minus 1 by 2. One case, another one you have to take as 5 plus 2x. Observe it carefully. Let p of x is equals to x cube plus 3x square plus 3x plus 1. Now, what you have to find out the immediate step when you are finding the remainder? You have to find 0 of. So 0 of x minus 1 by 2 is, that means x minus 1 by 2 is equals to 0, then x is equals to minus 1 by 2. If you transpose this side, you will get x is equals to 1 by 2. That means in place of x 1 by 2 you are substituting p of 1 by 2 is equals to, where you are substituting in this place x cube. x cube plus 3x square. In this place we are substituting, that is 1 by 2 whole cube plus 3 into 1 by 2 whole square plus 3 into 1 by 2 plus 1, which is equals to 1 by 2 whole cube is 1 by 8 plus 3 into 1 by 2 into 1 by, here you see 1 by 2 into cube is applicable for both numerator as well as denominator. So 1 into 1 into 1, 1, 2 cube, 2 into 2 into 2, that is 8. 3 into 1 by 2 square is 4 plus 3 into 1, 3 by 2 plus 1, which is equals to, look, 1 by 8 plus 3 into 1 by 4, 3 by 4 plus 3 by 2 plus 1. Now find out the LCM for this. LCM for all this is 8 is the LCM. 8 table 8 one time you get, so 1 into 1 plus 4 table 8 2 times you obtain, 2 into 3 6 plus 2 table 8 4 times, 4 3 is 12 plus, here you can write as 1 by 1 8, 8 ones are 8, so which is equals to 12 plus 8, 20, 20 plus 6, 26 plus 1, 27 by 8. Therefore, P of 1 by 2, P of 1 by 2 is equals to 27 by 8. 27 by 8. 27 by 8 is the remainder. Here we are applying remainder concept. Find the remainder. Next. Now we have one more question over here. This is x cube plus 3x square plus x plus 1 with 5 plus 2x. With 5 plus 2x, I just will erase this part. 5 plus 2x. So this is, now observe it again. Now fifth bit you see here. Fifth bit. What is fifth bit actually? 5 plus 2x. 5 plus 2x. This is the fifth bit. Again polynomial is same, that is p of x. Let p of x is equals to x cube plus 3x square plus 3x plus 1, as we are finding 0 of 5 plus 2x, 0 of 5 plus 2x is, which implies 5 plus 2x is equals to 0, then 2x is equals to minus 5, transpose minus 5 this side, plus 5 this side, it becomes minus 5, then x is equals to minus 5 by 2. That means in place of x now we are putting minus 5 by 2. So p of minus 5 by 2 is equals to y, which way we are substituting in this place, x cube plus 3x square plus 3x plus y. So 5 minus 5 by 2 whole cube plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1. Now the square cube is applicable for all these numbers, numerator as well as denominator. Minus 5 whole cube, minus 5 into minus 5 into minus 5. That is minus 5 into 5, 25. Minus into minus plus, plus into minus, minus 25 into 5, 125 by 8. Plus into, now plus 3 into 5 square is 25 by 2 square is 4. Plus into minus, minus 3 5s are 15 by 2 plus 1, which is equals to minus 125 by 8 plus 25 into 3 75 by 4 minus 15 by 2 plus, we write as 1 by 1 so that it will be easy for you to add. What step we are doing? We are taking LCM. For all this, LCM is 8. Now 8 table 8 one time you obtain, that is minus 125 plus 4 table 8 2 times, 2 into 75 is 150, then 2 table 8 4 times you obtain, 15 4s are 16, this is 60, minus is there, plus 1 table 8, 8 into 1, 8. Now we see here, minus 125, minus 60. Together, I am just adding those values in this. Negative values you add, then positive values you add, finally you subtract. 125 minus 160 is minus 185, and 150 plus 8, that is plus 158. Observe it. One is minus 185, another one is minus 158. So if you subtract, ignore the signs and subtract. Ignore the signs and subtract. Keep bigger number sign. 15 minus 8, 7. Then 7 minus 5, 2 minus. So 15 minus 7, 8. 7 minus 5 is 2. So that is 27. So which is equals to, here also you are obtaining same answer, minus 27 by 8. Therefore statement P of minus 5 by 2 is equals to minus 27 by 8. P of minus 5 by 2 is equals to minus 27 by 8. I hope you understood how to obtain the remainder by using remainder theorem. Now we see one more question from the same exercise 2.3. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Divided by x minus a. Here, let p of x is equals to x cube minus ax square plus 6x minus a. 6x minus a. As now we are dividing with this. So x minus a is the one which is we have to divide. So the 0 of x minus a is equals to 0. Then x is equals to transpose minus a this side, it will become plus a. Now we are substituting in this. P of a is equals to, in place of x we are substituting a. So a cube minus a into a square plus 6 into a minus a cube minus a square into a cube plus 6a minus a cube gets here, a cube minus a cube which gets cancelled, plus 6a minus a is equals to, that is 5a. So P of a is equals to 5a. In place of x we substituted value of a. This is the remainder. I hope you understood how to find the remainder. So in this same exercise, leftover questions are there. That is homework. Exercise 2.3, question number 1. First, third and fourth bit. And third question. In fourth bit he mentioned as x plus pi or x minus pi something. The pi value you no need to take as 22 by 7. You just write as a pi. In place of x you substitute as a minus pi, whatever according to the question. Pi square, pi cube, like that. No need to simplify as 22 by 7. This is the homework questions. So in this today's class we have discussed about remainder theorem, and we discussed the questions how to obtain the remainder if the degree of the linear polynomial is given polynomial is a linear polynomial, that is x minus a. Then how to obtain the remainder, not by actual division, by taking the 0 of the divisor, that value we substituted and then we obtain the remainder. This is the session what we have discussed today. I hope you understood. Thank you.